To the next question on the homework, which is all of the following properties increase as intermolecular forces increase, except one of these. And does anybody know which one does not increase as IMF increase?
Vapor pressure.
Thank you, Selden. It is vapor pressure. And the reason is, so all of these things like boiling point, which is, so a substance, which is a liquid, trying to go to a substance, which is a gas. Melting freezing point, well, that's going to be, and A is just some generic compound, so compound or atom is going to be solid to liquid, or vice versa. And all of these other ones, delta H vaporization, delta H fusion, are related to different properties, really. Actually, vaporization is this process. Fusion is this process right here. But you can see everything's going from liquid to gas, which is higher temperature, solid to liquid, which liquid is higher temperature, and vapor pressure. So as temperature increases, substances are more likely to be gases. And vapor pressure increases. And it's here that I'd just like to note that and this is something we've mentioned all the way back at the beginning of this course, is that there are sort of two competing forces. So as temperature increases, we've said that kinetic energy increases. And that kinetic energy tends to pull particles apart. Because they have more energy, they're more able to fly away and become gases. So as temperature increases, kinetic energy increases, and substances are eventually become gases. Become gases. And what do we know about gases? We know that gases have no intermolecular forces, or negligible intermolecular forces. So as temperature increases, eventually everything becomes a gas, and all intermolecular forces are irrelevant. As T decreases, so IMF become more important. And to the extent that almost every substance we know of will become solid because the IMF are strong enough to hold them in the solid phase. There's one notable exception to that. Does anybody know the one substance that they have not been able to turn into a solid? It's a little abstract. It's actually helium. So as far as I know, they've only been able to get helium to a liquid. And helium is an atom. It is nonpolar, as all atoms are, and it only has LDF, and it has so little molar mass that the intermolecular forces are not strong enough to make it into a solid. So IMF tends to hold materials together. Temperature tends to break them apart. And eventually, as you get to high enough temperature, pretty much everything, in fact, everything becomes a gas. Even metals and are gases inside stars. So Anyway, but the one that's different is vapor pressure, because the higher your vapor pressure, the lower your intermolecular forces are. Any questions about that?